This is gonna be good for everybody because we're talking about applying some of the stuff that you should have learned. The ones of you who taken electrical, or if you've already had electrical, you're supposed to know this stuff, okay? And so we're gonna strengthen your neural pathways. But whenever you learn something, you make a little neural connection, and every time you relearn this, you get it more and more and more. So if you just did something one time, you may forget how to do it later on. Like when I teach somebody how to read a mic, and they measure several things right, and then 4 or 5 days later, they come and say, hey, I forgot how to read this mic, can you walk me through it again, this kind of thing. So the more you do it, the more it'll become second nature. Now, well, hopefully you burn your Ohm's law by now. You know how to calculate wattage. That'll be to increase your expertise. Experts possess the ability to perform at a high level repeatedly. That's what we're shooting for. We want to be able to perform at a high level again and again and again. This guy that I know that's working at one shop over there said that they brought a car in that wouldn't start, and he was saying, look, the other mechanic said, you know, we need to put a crank sensor on this thing. And he said, why are you putting a crank sensor on it? Because I'm getting an RPM right here on the scan tool. And I said, no, we're going to put a crank sensor on it. So we put a crank sensor on it, didn't fix it, and then he pulled the distributor cap off and the rotor was busted. So, whatever, anyway. So everybody got to understand this right here. These two little circles right here, EIR, this is amps, that's resistance, that's volts. This is power, which would be watts, current, and volts. So if you take amps and multiply it times volts, you're going to get that. See that? So that's what this is about. So EIP. I got to remember how to do that. A 12-volt circuit is powering a bulb that is pulling 6 amps. So what is the bulb wattage? That's your first question for your test, guys. A 12-volt circuit is powering a bulb that's pulling 6 amps. So what's the bulb wattage? 6 amps, 12 volts. 6 times 12. If you have not memorized your multiplication tables, you should. I learned mine in the 3rd grade, and I've never forgot them. I taught my daughter her multiplication tables in one night, from 1 to 12. One night. You knew them all. Ohm's law. You won't use Ohm's law very much in the day-to-day grind of repairing vehicles. It's not going to happen. That's like the latent heat of vaporization and the latent heat of condensation. As far as you're not going to use that fixing a lot of vehicles. But you know it. 1 volt pushes 1 amp through 1 ohm. And you remember that. 1 volt, that's Ohm's law. 1 volt pushes 1 amp through 1 ohm. Voltage is the pressure, the amp's the flow, the ohm is the resistance. Say that with me. Memorize that. 1 volt pushes 1 amp through 1 ohm. Can you say it? Say it. This ain't rubber baby buggy bumpers.
1 amp.
No. Start 1 volt.
1 volt.
Pushes.
Through
1 amp through 1 ohm. You're going to have to write that down. There's going to come a question later that's going to have that as the answer. In this test, 1 volt pushes 1 amp through 1 ohm. All right, move on. All right, a 12-volt circuit is pulling 6 amps. What is the resistance of the load? You're using these same things. That into that equals what? 6 into 12 equals what? You guys should have learned this under Steve. All right. 6 into 12. All right. Now, we're engineers. They know all sorts of things, not the least of which is a lot of simple things like knowing how to make things work. You understand what's going on there? What's this guy doing with that chain in that sprocket?
Air intake.
Looks to me like he's using it for a throttle cable. See that? It's hooked to the throttle on that 4-barrel carburetor. All right. Mastering fundamentals. Anybody's success starts with a solid mastery fundamental. If you can master electrical fundamentals, you'll eventually achieve expert status by fixing electrical and other problems right the first time consistently. Matter of fact, if you go to a shop and they decide to send you to a school, particularly if it's a dealership shop, unless you have passed on their computer, and that's what this Electude stuff is part of it too. I was telling him the other day, there was a guy put to work at one of these dealerships over here, and he was a really good mechanic and fixed all kinds of stuff, but they had something kind of like Electude that the GM dealerships required you to do. He didn't think that was worth his time. He wouldn't do it, and they let him go. See? because he felt like, this is not worth my time, so I'm not gonna bother with it, I'm just gonna do this out here. So they said, you gotta get this stuff done so we can send you to this school in Atlanta or whatever. See what I mean? So everybody's gonna, you have to deal with that. It's just like if you go all the way through the whole thing and you don't have your elective done, don't expect to get passing grades. Or, you know, most of your elective done, not just a tiny little sliver of it at the very beginning. Really important. So, question 3, conventional versus electron theory. Conventional current flow theory says electrons flow which way? Some of you guys ought to know this. Conventional theory says electrons flow which way? From positive to negative or from negative to positive? Who knows? From positive to negative or from negative to positive? That's conventional current flow. That's as opposed to electron theory, right? Understanding voltage. Well, you know how to test it, how to interpret tests. Voltage can be defined as electrical pressure. Some of the people that teach electricity like to use water, you know, as voltage, water pressure as voltage and all. I've done that myself. Voltage is necessary for current to flow. Where there's no voltage, there's no flow. If battery voltage should be tested first. Anytime you're working on electrical problems, you need to make sure you got plenty of battery voltage. Plenty of battery voltage there. If you don't have plenty of battery voltage, everything else goes down the tubes. Also, low voltage feeding a starter is like the starter's locked up and it can burn a starter up and nothing flat. Be really careful about that. Understanding voltage and amperage. Voltage is only the command. Amperage, all of that current flow does the work. A resistance restricts amperage, and that reduces the amount of work that can be done in a system. That's why I've got you guys measuring voltage drop all the time, because voltage drop is an indicator of resistance in a circuit, right? And all of the voltage drops in a circuit are going to be, if you total them all up, they'll wind up being the same as the source voltage, okay? Lower voltage requires more amperage to get the same work done. If I was going to put a window unit in here, instead of having the central heat and air that we got, and I wanted one that was 10,000 BTUs, let's say. If I put one in here that plugged into a 110 volt outlet, it would consume twice as much power as a 220 of the same rating. Because 220 volts, you got more voltage, you need less amperage, just the way it is, okay? That's no matter what you're doing. But resistance breeds heat in connectors. Wires and heat causes damage that leads to more resistance and more heat. Like this right here. You'll see melted connectors like this. If you stay in this business and you do a lot of work, if you go to a switch a lot of times, you'll see a melted connector. Now sometimes that's because, where's the most common place you see melted connectors is of circuits driving fans, blower motors, radiator fans and all that, because those things pull a heck of a lot of amps. And whenever those terminals start to oxidize a little bit, they develop resistance, and they develop heat, then they start to oxidize even more, and they develop more resistance and more heat, and then after a while everything melts down and it starts to, it's like this. Now this looks like I went off a headlight switch, and if somebody puts a whole bunch of marker lamps down the running boards on their truck and they just scotch lock into that brown wire that's feeding the tail lights and leading on it, they'll cook a headlight switch in a flash. They can cook a wire harness if they do it, get really extreme on that. Voltage is in a closed path in the circuit must sum to zero. That's Kirchhoff's law number 1. Voltage drops being negative, followed by current through a resistor, while gains are positive, going through a battery from negative to positive terminal. Now the sum of the currents entering a node must equal the sum of the currents exiting a node. You know what I was telling you, like if you've got, whenever you're measuring your voltage coming from down all the way to the ground, you're using ground for a reference point, you're measuring 12 volts, 12 volts, 12 volts, 12 volts, then you get to your load, you don't have any voltage anymore. However, if you measure amperage everywhere in that circuit, it's going to be the same. If it's pulling 6 amps, it's going to be 6 amps all the way through the load, it's going to be 6 amps in the ground, going all the way to the ground. And that's, sort of like this. You don't need to really remember this guy's name, Onboard computers, when you're diagnosing computer-related circuits, computers communicate only in voltage, not in amperage. There is a test you can do where if when you go to the positive battery terminal to the signal return on your sensors, you can measure voltage drop in there. There should be a good clean signal. If you're doing an oscilloscope test and you can connect to your signal return circuit on your computer instead of hooking it directly to the battery, you're going to get a lot cleaner pattern that way. But the simple fact is you shouldn't have voltage drop between the negative battery terminal and that signal return wire over there. If you have voltage drop there, you're going to have voltages that are going to be skewed coming out of your sensor. That's just what it is. Computers have got to convert analog signals to digital signals to make their decisions. So it takes a signal that looks like this, and whenever it goes above that line, it considers it on. When it goes below that line, it considers it off, and it converts into that. We were told that in 1981, and when I went to General Motors School for a couple of days, because I had a Delco part supply. And she says the computer does not like analog signals. It has to convert them to digital signals in order to get something done. If an analog speed sensor kit reading flips back and forth between speed values, yet the scope waveform looks normal, you may have a bad analog to digital converter in the PCM, BCM, or whatever. All right, so a variable reluctance sensor produces what kind of signal? This is a variable reluctance sensor. This one on the front of this engine is a variable reluctance sensor. It's got a little magnet. It's got wire wrapped around it. Both ends of that wire that's wrapped around it goes out, and that puts out kind of a signal. What kind of a signal do you call that? You should be able, you can draw it if you don't know the name of it, okay? That's question number 4. Time to move on. Scope chip. Cam crank vehicle speed sensors usually produce an analog voltage. Not always. Not always. Usually. And it's important to remember the sensor's frequency pattern and signature are what it uses to determine a spinning shaft's input speed and position. And whenever you guys that are in engine performance, whenever you're wondering, you know how you get misfire codes? You get misfire codes because the engine control has learned what the normal pattern looks like when there's not any misfires. As a matter of fact, Chrysler used to call that the adaptive numerator. And when you were letting off, and they knew the crankshaft was just in a coast and it wasn't going to be speeding up and slowing down due to anything, it would actually store that waveform, and then it could, interpolate it based. And if the waveform changes, like if it slows down because one cylinder is not contributing, that's how. And it looks at the cam sensor and it determines which cylinder misfired, and that's how it throws you, your PO304 or whatever. Keep in mind, trigger and slope come into play when it needs to use interpreting a signal. Right there. I was showing some of y'all the other day that on this thing over here, you can fire that thing up, and it's going to start operating those injectors and firing those coils right away. This little board I got built over here. All you have to do to assassinate that is to take the 2 wires going to the crank sensor and reverse them. And in spite of the fact that you still got a signal, that engine controller refuses to recognize that signal because it sees that it's backwards. And it will start out showing RPM, and then the RPM goes away, even if you're looking at scan tool. And so I could take this vehicle out here if I decided I wanted to, like maybe one of these Fords, and I could swap the 2 crank sensor terminals around at the engine controller, which is very easy to do. And you can take it to shops all over the place, and they would be scratching their head for weeks trying to figure out what was wrong with it, or y'all could. I could beat y'all up with something like that too. Remember now that whenever you're in engine performance, you're going to have to figure out in a very short period of time what's wrong with about 4 vehicles. And we have all different kinds. Some of skipping, some of no start, all this kind of thing. Now, if you're in engine performance and you haven't done that, you're going to have some issues, right? So you got to be able to do that. And I'm not going to be able to hold your hand and fix it for you and then give you an A. That's not going to happen, right? So if you get an F, you get an F. If I look over here and I see a whole bunch of snaggletooths because you didn't do any worksheets, you didn't do any of your lectude, don't expect, hey, he likes me, so he'll give me a passing grade, and I can say, whoopee, I passed automotive. Go ahead and go, I failed because I didn't do my work, this kind of thing. That's how it works. This one guy came and says, hey, can I pull all my grades up between now and day after tomorrow when the grades are due? And I said, no, you can't do a whole semester's worth of work in 2 days. You're fired. Get out. So he had to go home. Anyway, if you connect the sensor wires backwards on some sensors, it can confuse the computer on some of the calls and start. That's what I saw that one go. Computer output signals are always digital. I mean, on or off voltage triggers. Sends digital triggers in several ways, pulse width modulation, and time. That's with injectors. They have a spike when the current's turned off, typically, unless there's a built-in diode that clamps that, like your AC clutch diode that we talked about that we missed yesterday. Right. So this right here, 10% duty cycle looks like this. It's off 90% of the time, and it's only on 10% of the time. Okay, 50% duty cycle means it's on half the time, it's off half the time. 90% means it's on 90% of the time and it's off. 100% duty cycle will be a straight line across the top. 0% duty cycle will be a straight line across the bottom. It's a duty cycle thing. See? Computer output signals that do that. They're practically the same thing. The dash lights and some solenoids are duty cycles, those are cars. Okay, computer output signals are always digital. That means on or off voltage triggers. Frequency, speed at which the vehicle is repeating. That's in other words, how fast is it doing it? Hertz is how many times per second is occurring. As a matter of fact, you'd be confused sometimes. They used to have on some of the 84 Lincoln Mark 7s that they used to work on. And in order to go into the airbag, I'm talking about the air suspension codes, as I remember, you were supposed to ground the wire and open and close the door 3 times or something, and then it would flash the code 1.8 Hertz. When I first heard that, I said, what the heck is 1.8 Hertz? You know, I mean, I know what Hertz means, like what if you smash your finger or something like that. You smash your finger today? Well, you smashed his finger today, and it hurt. That was grueling. That was a finger smash. You know, the other day, whenever you know. All right, so a Hall effect sensor produces what kind of signal? Hall effect sensor produces what kind of signal? That's the kind of sensor that's in this distributor. Is the kind that's in that one over there. Hall effect produces what kind of signal? Is your performance people, if you've been doing your electude, this will be snap click, you'll know exactly what I'm talking about. Because you'll actually have pictures, you'll have to have the stuff showing you a little animation on the screen where it's giving you all of that.
I just did it yesterday.
Huh?
I just did it yesterday.
Second-rate amateurs, it's supposed to burn in the neural pathway. Okay? Practice makes perfect. Hone your troubleshooting skills by using a scope to view inputs and outputs. Take stored captures and share them with other mechanics online. It helps. I'll tell you something else too. If you're used to seeing these patterns, or you're used to seeing the way the scan tool reads, you know, if you're used to seeing particular things, you'll actually be able to pull it out. The treasury agents that look at fake money, that's what the Secret Service is for, really, is keeping care, looking after our money. Now they also look after the president, but they look after our money. And what they do is they look at real money until they're sick of looking at it, and then they look at it some more. And whenever they have every little line and every little wiggle and every little everything monitored, but when they look at a bogus bill, they instantly know it. My wife is a bank teller, and she can get bills in there where they've washed a 5 and printed them to look like 100. I mean, you can hold that thing up and see the strip and everything. But if you look close, the strip will say $5, but it'll have old, you know, Ben Franklin on there and all that. I mean, but she can look at it and tell that it ain't right because she sees money all the time. Now the point is, if you look at all of this, when I first started, when I started working on some of this electronic ignition stuff in the mid '80s on some of these Fords and all, but they didn't have data stream in the mid '80s on the Fords. They didn't have till '88 on the Lincoln Continental. But I actually started measuring voltage on all the sensors on every car that came in there. And I got used to what those voltages were every time I do that. I got used to what the switches were supposed to be doing, various different little solenoid servos and all. And I could actually bam, 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 bam. I could tell you what was wrong with one most of the time within about 7 or 8 minutes, fix it in about another 20 minutes, and then, you know, then we get an hour and a half repair time and, you know, an hour labor and all that kind of stuff. And you could crank up some labor hours like that, you know. And don't feel guilty if you're getting paid for what you know. You know what I'm saying? Because more of what we do, a diagnostician gets more paid for what they know than what they do. But you got to be good at diagnosis. You know, if you can't find your fanny with both hands and don't know how to fix anything, then you're probably not going to last very long. They put you to sweeping the floor, washing cars, maybe changing oil, and they'll lower your pay. That's not really good. All right. So, Kirchhoff's law of voltage drop refers to the fact that voltage drops across a load, and a load is basically anything at resistance and does work. Measuring voltage drop, you're actually applying this load to resistance and turn current into heat. If I wire this up, and I wired in series with that, probably what's going to happen? Like, let's say that I hooked up from the battery to here, then I went from here to here, and then I went from here to ground. What's going to happen?
The motor's not going to run as...
The motor's not going to run. Well, what's going to happen?
It's going to split up your voltage.
I know, well, yes and no, but this light's going to come on, and that motor ain't going to go nowhere. Because that voltage is going to be dropped through that light bulb, and there's not going to be enough voltage to make that motor do nothing. You got that?
Is that right there?
Huh? What?
Is that right there?
Yeah, very similar, except that this is a headlight bulb. This is one of the halogen headlight bulbs. But whatever the weakest part of it is what's going to fire up. You know, your basic, it's going to think this is just a wire going to ground. Because this is actually, how much does this motor, how much does the headlight bulb pull in amps? Anybody know?
2 or 3 amps.
That's not too far off. It's about 5. It depends on whether you're on dim or bright headlight, or if you're burning them both. The little bulbs like that one over there that's got the tail and stoplight, you know, they usually, the tail light only burns about 0.8 of an amp or about less than that, so, and the stoplight is like 2.5 amps. See what I mean? You can measure that. You know, if you get used to that, you're pretty knowledgeable about that. Now, remember the importance of voltage drop testing. Resistance found in places might overlook, stuff you don't want it to be. You don't want it to have a cable that's got resistance in it, it's bad news. All right, knowing how voltage drop testing, we easily pinpoint the location of unwanted resistance in a circuit or connection. There's this farmer that I knew one time that had a tractor that wouldn't start out there. Battery cable looked clean, everything looked like it was pristine, and it had those molded battery cables, you know, where it has a cable made on the end of the you know, it didn't have, you know, screw cable. This was the factory stuff. But I found out there was voltage right here at the battery, but it wasn't making it into that cable. So where the lead and the copper went together inside that cable, there was no connection there. So I took the battery cable and I laid it over here on a piece of the frame on the tractor and beat the crap out of it and squished it, put it back on, you know, and that thing had whooped a bunch of people. Because it wasn't a dirty connection, it didn't look bad, but it was dropping every bit of the voltage between the terminal and the wire that was in the cable. First time I ever ran into that. And that was a 100% voltage drop. I didn't even have a voltmeter with me. I had a hammer and a wrench. That's all I had at the time. But I figured it out. Okay, so basically, anytime you're doing voltage drop testing, you're basically going to be hooked up. And this is not with your amp meter function. This is with your voltmeter function. You're going to be hooked up on the positive side of the circuit. Both connections are going to be made on the positive side, and both connections are going to be made on the negative side, depending on what you know, whether you're measuring voltage drop on the negative or positive side. Now, the left headlight is dimmer than the right one on a vehicle you're working on, but the bulb is new. Where would you connect your voltmeter leads first to do the voltage drop test on this problem? This headlight is burning dim, that one is burning normally. What you gonna do?
That's question 6.
Question 6, where are you gonna hook them up? You better be able to answer this question. You better be able to do this test if I hit you with it the last, you know, during our hands-on final exam, right? What you gonna do? There's your battery, there's your light. It's right here's the ground. Goes in there. Moving on. Uh-oh, we got 2 question 6s. Whoop, whoop, whoop. That's crashed and burned on that one, didn't it? The voltmeter is reading 3.8 volts when the starter is engaged. What needs to be done to fix this? Look how the voltmeter is hooked up. The voltmeter is hooked up between the big terminal that's coming from the battery and that big terminal that's going into the starter. There is a connection that's being made between here, and you're reading a 3.8 volts right there. What do we need to do to fix that problem? And of course, you know, this is the starter, that's the solenoid, this right here is the alternator, that's the battery, that's the meter with this little 3.8 volts up there sideways. Using voltage drop. An engine controller takes advantage of voltage drop by reading the voltage after a fixed resistor to determine the resistance and temperature and the coolant temperature sensor. Okay, so the coolant temperature sensor is actually read right here. So if you're not going to see a full 5 volts at your coolant temperature sensor, even if you disconnect it, you'll see like 4.6 or something like that, because it's got a current dropping resistor on the inside. So a variable resistor in this engine coolant sensor provides the changing input. In this case, a negative temperature coefficient thermistor. That means the hotter it gets, the less resistance it has. So the more voltage it shorts away. Now you start out with a cold engine, you're going to see 2.5, 3 volts, depending on the temperature. As you crank it up, the voltage on that sensor is going to go down, 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 down. Because the resistance goes down, voltage goes down, because it shorts more of it away, right? What a variable resistor does. All right, so you got dynamic rationality testing here. If you scope the signal wire of the MAF circuit at the sensor as well as the engine controller, MAF voltage originates at the sensor. This is the signal ground. If it's lower voltage to PCM, like for example, you got 4 volts up here, and you got 3.2 down there, you got something going on in between here, right? Tracking it down. That's how you do it. A few more of those, you'll have their range. Just like shooting a gun to the submarine. You go on this side, you go on that side, and you keep going back, and finally you find it. Okay, Ohm's law states what? What? What do you say? What is it? Can you write it down? Can you remember it? Did you burn it in? Don't play dumb with me. If I think the words in my mind 3 times, you should have time to write them down. Even if you misspell a few of them. Parasitic draw testing. on late model vehicles can be a time-consuming task. Waiting for modules to go to sleep and connecting and disconnecting circuits takes a lot of time. So if you disconnect the battery, and then you hook your meter, your amp meter in between the battery and that's okay, but you're going to walk away for sometimes an hour before all the modules get through with all the garbage they're doing and they go to sleep. But there's a better way. Now, some of you guys have done this on a worksheet I passed out already. All right. What amperage is the rating of this fuse? What amp rating is that fuse? That's question 8. Need a lifeline? You should have those memorized. You know the ones it's not, right? Parasitic draw testing. You get your meter and you hook it to those two, you're going to see some voltage drop because everywhere there is a connection, there is a little bit of voltage drop, right? And let's say that I open this here cover and I go through here and I check both sides of every fuse and I stumble across one that's dropping some voltage. I'm going to put my meter on the really low setting and I'm going to check both sides of every fuse, and if I see that meter reading something on one of those fuses, there's current flowing through that fuse going somewhere. You got it? Because if you don't have current flowing, you don't have voltage drop reading. When you're doing a voltage drop test on a starter circuit, you got to be spinning the starter. You're not going to be able to read any voltage drop. Current's got to be flowing. Got that? All right, don't forget that. One technique for finding this is like the other dude, touch both sides of her fuse. Now you can actually pop the covers off of these fuses right here and check those too. All right. There will only be voltage drop in a circuit when the circuit's closed and current's flowing. You can eliminate the fuses with no voltage drop. I'll tell you something else you can do. You can get your forward-looking infrared camera and point it at the fuse box, and if you find a fuse or a relay that's warm, good place to go looking for your parasitic drain. Amperage trace is taken with an inductive current probe. My inductive current probe that I had here, I think it kind of messed up in the cord got all broke up on it. So I took that one home. I tried to put a new cord on it, but I ordered another one. It should be here tomorrow. They provide a lot of information about what's really going on in the circuit. Now you can hook that into a meter, and you can read it that way, but what I like to do is put a BNC adapter on there, put it on my scope, do it like that. Diagnose electric motors, inductors, solenoids, that kind of thing. Scope and voltage and amperage on the same injector provides a view of the command as well as what happened. You got the opening of the injector pedal with the amperage waveform. You can see that happen. When it clicks, that thing opens up. And you can see the closing of it right here on the down. See that? Now this is the amp, and this is the volts. Whenever that thing turns on, it pulls it to 0. When it releases it, you notice the amps drop to 0 and the voltage spikes up. That's just the way it is. Voltage waveforms are captured using what kind of probe? What did you see me using a minute ago?
Right.
Voltage waveforms are captured using what kind of probe? I'm just going to hook up to them, right? Amperage waveform should be captured using what kind of probe? What I just show you? 2 slides ago?
Well, no, question 9, I thought we were on 10.
Maybe it's because there were 2 question 6s. I messed up.
Oh.
Just fix that. Alright. That was a funny little meme that I saw one of my colleagues put on Facebook. I'll show you that. I've actually heard that question asked me before. Haven't done anything all semester, but what can I do in the next 5 minutes to bring my grade up? You know what the problem with that is? Let's say that I really feel sorry for somebody and I give them a passing grade even though they didn't pass. They go tell everybody that's going to enroll, all you got to do is he'll feel sorry for you and he'll pass you. You don't have to do nothing. That's why I don't do that. You get an F, you make an F. That way you'll tell people, you better do your work in there, you'll get an F. Isn't that right, Robbie? Robbie, you know that? You guys know that? You see that? Yeah. You know, the thing about, hey, I'm helping him, this kind of thing. You can help him all you want to, but at the end of the time, you're going to be one hurting, not him. You helped him, you can help yourself. Don't you love that? Read those, remember them, burn them in. If you don't like work, you won't like any job. No job, it doesn't sometimes feel like you're in a rut. Get used to having days like that. Easy jobs don't pay well. Do they? No, they don't. Nobody owes you anything you didn't earn. Here's one last little thing too. The government doesn't have any money it did not first take from somebody else.
True.
Think about that. I mean, if you're wanting government money, that means you want everybody else to pay your way. Got it? That's a good deal.